function that we call modulus, function of the form f of x is equal to, say, x. It's called the modulus function. The output function is always a positive number if it is sitting like this. We have two families of graphs of this function. The first one being this one, and the second one being f of x is equal to negative modulus of x. So the first one is graphed as two straight lines that are being reflected. The second one are the same two straight lines now facing down. This is how these graphs look like. We have only these two shapes. Now, why then do they look like this? You know, if I tell you to sketch a line y is equal to x, what you do is some people like making a table, you make a table. If you're making a table, you put some values. If you get x is -1, y will also be -1 because they are equal. So the point here, so when you draw a straight line of this form. Then we tell you to draw y is equal to -x. Well, it's almost the same thing, except now any value of y that you get, if I get x is -1, then I'll have y is equal to -1, which is equal to 1. So I'll get 1, so meaning that I'll have a line up here. The same line continues down. That's what I'll have. That's x, y, like this. But when we talk about modulus will combine these two lines. And then at the point where they are meeting, it will choose which side to take. Because we're defining this as x if x is greater or equal to 0. And the very thing is defined as -x if x is less than 0. That's the definition of the modulus of x. The idea of the modulus is to make a number positive. So if I take -2, I'll get the number +2. If I get +2, I'll get the number +2. This is the reason why these numbers are always like that. So when I define the modulus of x to be x when x is greater than or equal to 0, I mean, if the number is already positive, I mean, use it as it is. But if it is negative, multiply it by another negative to make it positive. I hope that sits well. Now, how do you sketch? You go straight to the sketches now. Examples. Sketch 1. F of x is equal to x plus 3. Solution to the graph. Step 1. Find the starting point. By equating the starting point by equating the inner part of the modulus to 0. So we'll get x plus 3 in this case and equate it to 0. And then x is equal to -3. When you get this value, you pick this value, substitute it in the function f. So what is f of -3? We'll get -3 plus 3, which is equal to 0, which is 0. This means that the starting point is -3, 0, like that. Then, if this is the case, then you say, well, I'm now ready to sketch. And this is how you sketch. You pick the number -3, 0 as a point. This is the point. Then, where now do you go? Do you take it up or you take it down? Say, okay, I'll pick a number bigger than -3 and less than -3. Then I'll know where it is going. So let's pick 0 on the right. What is f of 0? We get 0 plus 3, which is equal to modulus of 3, which is just 3. So there we get 3. Let's pick -4. I will have -4 plus 3, which is equal to -1, which is equal to +1 as it comes out of the modulus. So when we use -4, we're still getting a number above. This means that we'll have this line, another one will go up, since we only have 2 shapes that we expect. This is how this is how the function comes out. Is that okay?
Excuse me, sir.
Huh?
Is this the first example?
Yes.
Okay.
We also have this. You know what I mean? Let's forget about it. Three is just the same thing as what we are doing when you're sketching the rational functions. When we are sketching the radical functions, we are picking, after getting the starting point for radical, we are picking a number bigger than the starting point and less than. So here I've used a number bigger than -3, which is 0, and a number less than -3, which is -4. So that I can just know where the lines are they going up or they are going down. Remember, you always have 2 options, whether maybe case 1 or case 2, meaning going up or going down. Don't worry. If you have just joined now, the good part is you are here. Example 2. Yeah, sketching f of x is equal to -2 plus 3 minus x. Okay, so again, you start with the starting point. The starting point, so I get 3 minus x equal to 0. I'll get x is equal to 3 this time around. And then I get that number 3, substitute it in f.
Excuse me, sir. We're supposed to leave out the -2 when finding the coordinates.
When for the x coordinate, you leave out -2. Just pick what is inside the modulus.
We just pick what is in the modulus.
Yes, for you to get the x coordinate of the starting point.
Okay, thank you.
Since your point will be x, y, the x you get from the modulus. Then the y now, you would substitute in the whole function the value of x that you found from the modulus. So f of 3 is -2 plus 3 minus 3. This is the same as -2. Whether you substitute or not, after you get the x, when you take that value in f, you'll be getting the number standing alone, this number here. So now we have a starting point at the point 3, comma -2, like that. Symptom. I think the problem is not the speed. Problem is the name. Okay, so that's our starting point. If I have a starting point, then I sketch. Starting point is 3, comma -2. Here. Then you substitute 0 in the function. So we get f of 0. This will be -2 plus 3 minus 0, which is -2 plus 3, which is equal to 1. So we have 0, 1. Then we know that this graph is going to be a graph of this nature. Then it will go up the other side. Even if I don't substitute the number on the right. So we know this number is 1. We need to know this one and this one. So we have 3, comma -2. Then we pick now. For us to know these two values, the x-intercept, you equate the function f to 0. How do you equate? For you to equate this function to 0, you get the whole function, -2 plus the absolute value of 3 minus x is equal to 0. Then you can take -2 to the other side so that you get 3 minus x is equal to +2. When you have +2 there, This is the modulus. How do you define the modulus? We said it will always be in two pieces, plus or minus 3 minus x is equal to 2. Then I'll pick the plus one. So this implies that 3 minus x is equal to 2, or negative 3 minus x is equal to 2. So this one here is the same as negative x is equal to 2 minus 3, which is the same as negative x is equal to negative 1. Divide by neg, divide by neg. X is equal to 1. When you go to the other side, you multiply by negative. I will get negative 3 plus x is equal to 2. So that we get x is equal to 2 plus 3, giving us 5. This means that this number here is 5 and the other one is 1. How do you know? You have a 3 in between, so you know 3 will separate.
1, yeah, that's minus the change, so 5.
So that's how you get this sketch.
Sir, can you explain again? My network is bad.
So, oh, is the message? All right. We're in Osaka.
Sir, can you explain again?
Okay. We explain again. The first thing, the starting point, you equate this part here to 0. 3 minus x is equal to 0. Then you say x is equal to 3, solving this one. You take this x other side to be positive, it will remain positive. So this is the value of x. This value of x you put here, comma, you are now looking for this one. This one, you pick the number standing alone. If this number is not there, then you pick 0, as you can see in this case. Because there was no number standing alone, then we picked 0. Then from there, or if that is too much for you, you can substitute this number in the function f. When you solve, you get the number that you do not want to pick here, you get it here. And then put it here. So now I have the starting point, 3, negative 2. From there, because for this graph, there will always be the x at the y-intercept. So I get the y-intercept. The y-intercept is 1. By substituting 0 throughout the function, I get 1. Oh yeah. If it's 1, then I draw a line going up. The other line cannot go this side. It will go up. So I have the whole sketch. But you have this and this one here, the x-intercepts. Then now you have an equation. You equate this to 0, it becomes an equation. An equation.
Excuse me, sir. How do you get the x-intercepts like this 1 and 5? I'm a bit confused.
So we equate the whole function to 0.
Okay.
So now the function is here. We equate it to 0. And then this is negative 2. We take it the other side. It will be positive 2. Then to remove something from the modulus, you make it a plus and the other one minus, equal to the number on the right. So that the plus 1 will be equal to 2. The minus 1 will still be equal to 2. And then you solve the plus 1, we get x is equal to 1. Solve the minus 1, we get x is equal to 5. Because there's a 3 in between, it means that 5 can only be on the right of 3 and 1 on the left of 3.
Okay, so in short, you need to solve the equation first before you graph the graph. Not the graph, I mean.
Yeah. What you
The
mean is
question.
right.
Sorry?
What you mean is very right.
I'm asking, so we need to solve the equation first because I saw that you plotted the graph before finding 1 and 5. So I'm asking, are we supposed to solve the equation first before we plot the graph?
That is the right way, yes.
Okay, thank you.
But because I sketched without solving those first, because I knew that I found my Y-intercept. The only way it could be 1, starting from 3, is when the graph cuts it on the right of 0 for it to go to 1. Otherwise, the best is you first equate the graph, the function to 0 and see after you find the Y-intercept. Three. F of x is equal to -2 minus third value of 2x minus 4 minus 5. Two x minus 5 is equal to 0. This implies that 2x is equal to 5 divided by 2. X is equal to 5 over 2. Meaning that the starting point is the point 5 over 2 comma -2. Then I can have the sketch. Five over 2 comma -2. Then we'll find the Y-intercept first. The Y-intercept is equal to, it's going to be f of 0. That is -2 minus 2 by 0 minus 5. This is -2 minus 0 minus 5. This is -2 minus 5, which is -7. Okay. So now before you start asking me, I want to show you that the inside is the same as 5. The negative can come out, whereas 5 is still inside the modulus. So that as it comes out, we only have 1 minus there, giving us -7. So this being the Y-intercept, -7, it means that the graph does not have the x-intercepts. So I'll have this sketch here and done. Hello.
Without making imagination, try to solve for X-intercept. We see what is going to have it.
It's not possible.
We want to see if you have an imaginary number or whatever.
If you are a man, you don't need to see if you can conceive. You automatically know what I can conceive. If you force this -2 minus 2x minus this to 0, what will happen is you'll be saying, then I have -2x minus 5 equal to 2. Equal to 2. Divide by -1, divide by -1, then 2x minus 5 is equal to -2. This thing has never happened. It has never happened in this world. The modulus is meant to give us positives. It can never produce a negative. That's the reason why when we had -5 here, it started by being 5. Even inside, the negative could not survive. Then now 5 came out as 5. Because the reason why modulus was introduced, it was to help us make a function positive. So that's the only purpose of using modulus. If it loses that power of making a negative number positive, then it will be useless. And if you are given this equation to solve, you just say solution set empty. That's the only thing that you say there. Why empty? Because you have 2x minus 5 in the modulus giving you negative. There's no such value x that can do that. What has the -2 done? Charles and Muson. What has -2 done? Can you speak? What has -2 done? Charles. It's fine, Havan. Muzonda. It's fine. Charles is still cancel. If you pick this number 5/2 and take it in the function f of 5/2, it will give us -2 minus 2 5/2 minus 5. These will cancel. So you get -2 minus 0, which is -2. Okay, so this Zoom will cut this meeting. When we rejoin, we are rejoining at exactly 19 hours, 10 minutes break. We'll be doing equations of modulus and radical, and then questions that you have. So that in Wednesday's class, that's when we look at the alpha, beta, and then Friday and Saturday, we'll be revising. So let's log out and log back after 10 minutes. 9 minutes now, 19 hours.